Okay, and now finally basicity of amines. So the base means H plus acceptor or electron donor is a base. Now in organic compounds, amines are being discussed as a basis. So it is in amine that nitrogen has a non-bonding electron, lone pair of electrons. So it is the electron donor or proton acceptor. So as a result, proton accepting, that is converted into RNH3 plus. This is the conjugate acid. This is a conjugate acid. Now as in the case of acidic nature, here basic nature is also explained on the basis of the stability of this conjugate acid. So in case of the conjugate base of carboxylic acids or of alcohols, anion is the conjugate base. But in this case, conjugate base is cation. Sorry, conjugate acid is cation. So here cations are stabilized by the electron donating groups. That means here plus psi groups. Because here by donating nature, this magnitude of the positive charge is decreases. That means here there is a dispersal of the positive charge is possible by the electron donating groups. So here by the presence of the electron donating groups, the basic nature increases. That means here higher the stability of the conjugate acid, more basic nature, because your conjugate acid is more stable. That conjugate acid is stabilized by the plus psi effect, electron donating nature. Or in another way, you can explain like this here. This alkyl group, of course, whatever it is, if it is an electron donating group, that group increases more electron density on the nitrogen. So if around the nitrogen there is a higher electron density, it has a more tendency to donate electrons to the proton. So in any manner, that molecule requires plus psi groups. The plus psi group increase the electron density, or the plus psi group increase the stability of this cation. That is nothing but conjugate acid. Now basicity depends on stability of the conjugate acid, nothing but plus psi effect. So like in acidic nature, higher Ka value, higher acidic compound. So here higher Kb, strong base, or higher pKb, weaker base. So you have to remember this. This terms Kb, Ka in ionic equilibrium and chemical equilibrium. So now here, so finally we are coming to the one conclusion, that is basicity of any compound depends on the plus psi effect. So presence of the plus psi groups, electron donating groups, basic nature increases. Now here, this is ammonia, NH3 and methylamine, and this is the ethyl amine. Now here among these, this ethyl is a strong plus psi group than the methyl. So this one increase more electron density, and methyl slightly increase electron density. Hydrogen does not increase the electron density or decrease the electron density. So here ethylamine more basic, next methylamine and ammonia. Now next here, second example, this is a methyl group and this is the tertiary butyl group. Tertiary butyl group is a strong plus psi group. So that strong plus psi group increase the more electron density on the nitrogen. So it has a higher electron density. So it has a more tendency to donate H plus ions. Or conjugate acid, that is a cation, is more stabilized by this tertiary butyl group. So conjugate acid is CH3. This one becomes NH3 plus this cation is more stabilized by the strong plus psi group. So it is a more basic compound. So first suppose here, among these three, which compound has a higher Kb value? This compound has a higher Kb value. Which compound has a higher pKb value? This compound has a higher pKb value. So that means your higher pKb means less basic in nature. Now another example, this methylamine and this is aniline. In aniline, this lone pair of electrons are involved in a resonance. So here this aniline has a less tendency to donate this electron pair to the H plus, that means to the acid. because this are engaged with this benzene ring. But in this case here there is no resonance, so these electrons are freely available for the proton. So here this is the aliphatic amines, we can say this is the aromatic amine, because yeah, that NH2 group is directly attached to the aromatic ring, so these are the considered as a aromatic amines. So aromatic amines are less basic than the aliphatic amines. Okay. But in case of the alcohols, phenols are more acidic than the ethyl alcohol, because your conjugate base is stabilized by the resonance. There is a different aspect, so that we have to observe. Now this is ethylamine and this is of course fluoroethylamine. This fluorine is a minus I group. So that minus I group withdraw electron density, that decrease somewhat electron density on the nitrogen. So it has a less tendency to donate electrons to the acid. So that's it is less acidic, less basic in nature. So this is the strong base when compared to this compound. Now this is ethylamine, this is amine, this is imine, and this is cyanide, you know, this CN cyanide. So this nitrogen on the sp3 lone pair on the sp3 nitrogen, this lone pair on the sp2 nitrogen, this lone pair on the sp nitrogen. So generally here with increasing s character electronegativity increases. So with increasing electronegativity, that nitrogen has a less tendency to donate the electrons to the proton, because here more electronegativity of the nitrogen that holds electron density very tightly, so it is a less basic in nature. And this one is the sp3 nitrogen, is a less electronegative when compared to sp2 and sp. It has a more tendency to donate, to lose electrons, so that's why it is a more basic in nature. So very important point, with increasing s character electronegativity increases, so that holds electrons very tightly, so that has a very less tendency to donate electrons to the acid. Now here coming to the next example. So this is sp3 nitrogen and this is sp2 nitrogen. Now sp3 nitrogen, this is also sp3 nitrogen. So here sp2 nitrogen less basic in nature because of the electronegativity. So first this is a more basic compound. Now between these two is sp3 here sp3. Here this one is acting as a minus I group, this one acting as a minus I group. So with minus I effect, that minus I group decrease the basic nature, that withdraw electron density on the nitrogen. So first of all here this compound has no minus I group, so that's why it is more basic in nature. Now between these two, here oxygen is a strong minus I group than the sulfur. So here this sulfur containing amine is a more basic D, next C, and sp2 least. Now next here this is a dimethylamine, this is the diethylamine. Ethyl is a strong plus I group, so it is a more basic in nature. Now this is the alcohol. Of course here this alcohol OH group also contains non-bonding electron pair, so it may acting as base. Now this one non-bonding electrons, of course we are discussing that this is the base. Between these two here nitrogen is the less electronegative, so that can easily transfer its electrons to the proton, so that's why more basic in nature. But alcohols are less basic because oxygen is more electronegative element, so that holds electron density very tightly. It has a very poor tendency to donate electrons to the proton, that's why less basic in nature. Now here ethoxide ion, tertiary butoxide ion, ethoxide ion, tertiary butoxide ion. So generally we discussed already, we said that tertiary butyl alcohol and ethyl alcohol. Ethyl alcohol is a more acidic compound. So conjugate base of ethyl alcohol is ethoxide ion and conjugate base of tertiary butyl alcohol is a tertiary butoxide ion. So you are studying in the equilibrium chapter, the conjugate base of weaker acid is a strong base. For example, ethyl alcohol is a strong acid when compared to tertiary butyl alcohol. So here conjugate base of tertiary butyl alcohol is a strong base than ethyl alcohol. And we can say here this tertiary butyl group is the donating group. So with the presence of donating group, basic nature increases. Now coming to some more examples. So here water and ammonia. So between these two, here water is slightly more acidic in nature. Now next here, of course, here conjugate base OH minus, here conjugate base NH2 minus. So conjugate base, this is a weaker acid, so conjugate base is a strong base. Now here water and ammonia, basicity, ammonia is more basic. Now here this water and NH2, this NH2 minus is more basic because you have more electron density. Here there is a negative charge, more electron density, so it is a more basic in nature. And OH minus NH. So generally here water and ammonia, ammonia is a more basic. Now here OH minus and ammonia, but here OH minus is strong base because here this one has a more electron density. It is a negatively charged species. It is a more electron density. It has a higher tendency to donate electrons when compared to neutral ammonia. So OH minus strong base than the NH.